Okay, in this video, we're going to look at what we call polynomial functions. So we're going to look at a specific type of function. A function p, so I've used the letter p instead of f we normally use, p because it's polynomial. So function p is called a polynomial if it's of this form. So, I mean, it looks kind of intimidating at first, it's a big equation, but it's really something you've seen many, many times before. So p at x is equal to a at n times x to the n plus a at n minus 1, x to the n minus 1 plus, and then you could have any number of terms here, plus a squared x squared, sorry, a2x squared plus a1x to the power of 1, you don't need that, plus a to the 0. Where n is some positive integer, so depending on the size of n, that would determine how many terms you have. N might be 2, so you only have sort of these last 3 terms. You wouldn't have these first ones. If n was 1, you'd just have sort of these 2 terms. Some other things you're going to want to know. These numbers ai, so this an minus 1, a2, a1, a0, these are just real numbers. So any numbers. A lot of times they're integers, but they don't have to be. They could be any real number. We call these the coefficients. So you should know that term. The highest degree exponent n. So usually that's the one we write first. Usually we write it in descending order of the powers on x. But whatever the highest number is, even if it's not the first one, even if it's not in order, whatever this number n is, we call that the degree of the polynomial. Okay, so you should know what a degree means. And the coefficient of the term with the highest degree, so usually that's the first one again, because usually we write it highest power first. So in this case, a to the n, that's called your leading coefficient. So these two terms are important, so the concept of a degree and a leading coefficient, because the degree and the leading coefficient are going to tell us a lot about the polynomial. It's basically going to determine what type of polynomial we have and what it looks like, what the graph will look like. Okay, so I'm going to start by just going over a few polynomials, many of which you've seen before. So we'll start with an easy one, a polynomial of degree 1. So if n is 1, the degree is 1, then we call this a linear polynomial, or a linear function. So that's a function. So going back to that definition up here, n is equal to 1. So you really don't have these terms. You just have sort of these two right here, because your power on x would be 1. Usually we write the equation like this. Oops, sorry, I'll write f at x. So f at x equals, usually we're going to write mx plus b. And really, I've just, instead of writing a for my coefficient, remember up here I wrote a1. Usually for lines, we write m. M is just the coefficient. Mx plus b, so that's my constant. B is my a naught from over here. So I'm just using different letters because those are the letters we usually use for linear. You should be very familiar with this function. I mean, it was basically all of grade 9 dealt with linear equations. So we know that that produces a straight line. So that linear function was really a polynomial. Another type of polynomial, if your degree is 2, that's what we call a quadratic function. So that would be one of the form ax squared, and then usually instead of writing another a, we'd write bx plus c. Right? So that's just adding one more term. So now we have ax squared plus, and instead of a1 usually we use b, and instead of a naught we use c. Doesn't matter the letters you use. So you should be familiar with quadratics, right? Grade 9 for linears, grade 10 for quadratics. So grade 9 and 10, you're dealing with two specific types of polynomials. You probably in grade 11, you didn't spend the whole year doing this, but you looked at another type of polynomial, and that would be a third degree polynomial, a cubic function. So a cubic function just adds one more term. So this would be 1ax cubed plus And then a lot of times we'd write bx. It doesn't matter what letters you use for the coefficients, but usually we write it like this. N equals 4. You're going to have what we call a quartic. So that would be, now your highest power is going to be 4. So x to the 4 plus, and then we use the same letters, bx cubed plus cx squared plus dx, and then you have a constant term, e. Could even go to 5, and this is what we call a quintic. So that would be f at x, and now we're just adding one more term with one higher power, so x to the 5 plus bx to the 4 plus cx cubed plus dx squared plus ex plus d. You could actually, or sorry, plus f. At this point, we might start actually going and using like a1, a2, a3, just because, you know, using this many letters, different letters for all the coefficient. I mean, we're just getting a lot of letters, but it doesn't matter what letters you use, really. And you could keep going, right? You could do a 6-degree polynomial. Don't worry about the names for a 6-degree polynomial. Just after quintic, it's probably sufficient to just say a polynomial of degree 6. I mean, it's not necessary to memorize names of polynomials of higher degree. I could actually add one more, and that would be a polynomial of degree 0. That's just a constant function. So that would be the polynomial f at x, and then the highest power is 0. So we'd have a 0 polynomial, so there wouldn't even be this term. It would just be the constant. And usually the letter, well, it doesn't really matter what letter you use. I'll use the letter A for my constant. So we know what that function looks like. You would have seen that in grade 9. That's just a horizontal line. Okay, so those are some different types of polynomials. All these polynomials have some things in common, some things different. So we'll look at sort of what the graphs of these look like. But one thing useful to know is the domain of every polynomial. The domain of a polynomial, unless you restrict it for some reason, but in general, the domain of a polynomial is all real numbers. So we could sum in any number for x into any of these functions, and it would be okay. We'd get a number. So the domain of any polynomial is the set of all real numbers. So that would be the set of all x such that x is a real number. That's your domain.